All right, awesome.
All right, says recording, and now we're good to go. We are A1 in the chat. A1, A1. So welcome everybody back to Boost in Motion, guys. And today I have Mike Mixon from Dropbear LLC.
That's correct.
Okay, so if you guys don't know, he's the guy, the owner of the company, right?
Yeah,
Okay.
yeah, the owner and the mastermind.
That's going to be developing some of the larger big turbo kits for the VR30 community, Q50 and Q60. And also, just to jump right into it, so I don't want to have any confusions. So is Dropbear anyway affiliated with RGM manufacturing?
So we stemmed out of RJ manufacturing. So one of the things that kind of happened was, as RJ manufacturing started to grow, they started getting more and more business from the healthcare industry as well as aerospace. And so that being extremely profitable, and especially with the COVID stuff, they wanted to branch out and do more of that. So it allowed me to kind of take over the motorsport side of the business and really kind of grow it and give it the attention it needed.
Okay.
They're growing as a business, and at that point it was like, you're either robbing Peter to pay Paul, and they wanted to make sure that all their customers got as much attention as they needed. So
it's a subdivision, I would assume, like a subdivision. Like, all right,
yeah,
it's like Infinity, then you have IPL.
Well, I mean, in respect to, this is a separate business, like completely different. Yeah, I own this business outright.
Okay.
RJ Manufacturing, we do work with them. They do some of our CNC work, but we also work with other providers and manufacturers as well to kind of bring solutions.
All right. Okay. So what is your background? Background in the sense of the car world and everything like that. It's good to let people know, the person behind it,
Yeah, so I grew up in a motorsports environment. My dad had sports cars, and it was one of the biggest driving factors. I was one of those kids that obligatory Lamborghini exotic car posters, being like, one day I'm going to own one of those.
Yeah.
Which ended up driving me to build my 370Z the way I did.
Okay.
So I went doing that. I raced motorcycles, did a lot of, working in the motorcycle industry for a good while, and ended up, saying, hey, I want to go and make my own products. So, we found some things that we were dealing with in racing. We wanted to build our own products. So I reached out to like Ravi Dalwani, who runs the motorsports division over at CSF.
Okay.
I designed a work style radiator, but we implemented some technologies that hadn't been done in the industry before. Okay. So typically on a motorcycle radiator, they're about 12 inches tall at max. Yeah. We had one that was like almost 30 inches tall, full contoured shaped, radiused, multiple passes through, had the ability to be modular, to switch out the oil coolers in it and things of that nature.
Pretty dope.
So really cool technology.
Yeah, I'm not really in the motorcycle realm, but from what you're telling me, that sounds actually pretty dope.
Yeah, so that was kind of like my first forte of making my own products. And that was probably back in the early, like right around 2010 when I started building my 370Z. Outside of that, I'd just been doing help with R&D, with other manufacturers such as Graves Motorsports and stuff like that. And just working with different pro riders and manufacturers to try to test things out and really try to, give some experience behind it and say, hey, this works, this doesn't work. I was actually going to go to school for aeronautical engineering, but my idea was to go and be a jet fighter pilot and test pilot. But given my height, 6'2", it disqualified me for a lot of the things that I wanted to do.
Yeah.
Yeah. So when you try to get into those cockpits, it's really a tight squeeze. You're like scooching down in there just to get up under the canopy. So, at that point, I was like, I'm going to take a regular career and decided to jump into the technology world. So,
and it seems like it's been working great for you. So, when it comes to the VHR platform, what's some of the products you have developed or worked on developing for the VHR 370?
So, for the VHR platform, done everything from 7AT transmission builds, working with how do we improve the, somewhat weak 7AT. So we did a lot of things with basically doing a triple plate torque converter that hadn't been done before. So that took a little bit of engineering to be able to get that to work. Then we also created a way to actually put in more clutch plates. So a lot of people on the VHR 7ATs, the RE7s, they pretty much just say, hey, we're just going to throw in new plates. But what we actually do is go in and machine the buckets so that you can actually put more additional steel and carbon plates in. So we had an additional 12 plates were added to a factory transmission, which wasn't done by anyone else. And that's been holding up really well for a lot of our clients. Additionally, worked on the Gtr intake conversion. So did a lot of the R&D and beta testing for that. That was actually one of my first fortes in with RJ Manufacturing, was doing that. And then also worked with them on upgrading their closed deck blocks, looking at, doing billet main girdle reinforcements, things that kind of help, give the motors longevity at the higher horsepower levels. And then from there, I was one of the primary head designers for their Whipple supercharger kit.
For what car?
For the 370Zs and the G37s.
Oh, okay. I was thinking about, when you said supercharger, I just went instantly to Mustangs. That's it.
Yeah.
I thought about Mustangs. All right. So, damn, seems like you're really definitely been in this for quite a while. And it's really good. I just want to say I'm super appreciative of just getting you on video, because it's so good. I like to give my viewers just the information and to actually meet the people that's behind the R&D that goes into a lot of these products. Now, I did read in a forum, and it was quite funny, but if it was up to you, billet over forge. I just want to ask you that. Billet over forge.
Okay. Yeah, so I find it funny when people try to compare the two, because they both have their pros and cons, right? So the forgings, the main reason that manufacturers go to forgings, one, it's less expensive. Okay, right off the bat, raw materials less expensive. They can buy the blanks already done. But what happens is you have like the small hole for the wrist pin, you have the large hole for the crank. And when you do a forging, what happens is you get a grain structure that supports that area where you're getting pulling and compressive force. So if you're doing a lot of pulling on it,
the heat expansion, right? I would assume.
No, it's more of as the piston comes down and another piston has to go up, that force of pulling it back, pulling it apart.
Okay.
Yeah, that's where you're getting the strength of, so that you're not worried about it bending and breaking there. Versus a billet has a more uniform grain structure, which actually gives it less ability for it to bend. So it's going to be stronger in that respect. It's also going to be a lot more uniform from top to bottom, and consistency across rod to rod to rod. There's a reason why Carrillo uses billet rods, and it's been proven to work well. It really also depends on the application too, the type of motor you're running, what the piston size is, piston weight, your wrist pin sizes, the crank angle, like how much rotation you're getting out of it. So if it's like my 370Z, we were running a 4.5 liter in it. So we ran a 96 millimeter stroke. Factory is 86. So we ran 10 millimeters more of stroke, which is a lot. And then we also ran 100 millimeter pistons, which is a lot of weight. So in that respect, we ran forged pistons on that because there was a lot of weight being pulled back and forth. We wanted to make sure that was doing well. But when we went down to 4 liters, we went to a billet rod, mainly because we wanted that strength, because we were going to be adding more and more boost on it, and there was going to be a lot more compressive force on that rod, and we didn't want it to bend. So that's really what it comes down to, is there's pros and cons to both. We chose billets, one, because we could be more consistent with the weights, more consistent with the quality, and it fit the need for the application. So we're running at 80, I think it's 8686 on stroke and bore. So in that respect, it's not a lot of weight, and especially if you're throwing billet or forged pistons at this, you're reducing the weight even further. So when you're talking about mean piston speed and the force associated to that piston speed going back and forth, as you lower that weight, the strain on the rod is less and less. So we want to make sure that one, we give a solid product that's going to be consistent. And we're going to be going through plethora of tests. We're going through full metallurgy tests. We're going through heat treatment cycles. We're going to be looking at, having them, I'm trying to remember the name of it, drawing a blank. But we're going to do some other post-process treatments to it just to make sure that, it is going to be like the strongest rod that we can possibly make. Yeah, and we've already done.
Is this also going to translate even over into the VR community too? The same type of strength tests and everything?
That's what we're doing for the VR community. We're right now, our focus is more on the VR community than it is on the VHR and the VQ motors. We've noticed a trend that, as the price of the vehicles tend to drop, people who aren't, necessarily able to spend on the higher priced items, they tend to want to get, I just want to do a budget build, give me $500 rods and go from there. And for us, that's not, doing a billet perspective, that's not cost effective for us, and we don't have the margins to basically do that. We focus on small batch, not large mass quantities, such as like Manly or Carrillo or even Eagle or whatever. They can make thousands of rods very easily. So we're looking at, for our first batch of it's going to be 25 sets of rods.
Okay. Now we're on the VR community. So I remember seeing that you developed a meth kit, a meth port injection kit. Talk about that a little bit for the community. So
we have our direct port meth injection kit, and so we've actually partnered with ProMeth on that. So we worked with them to basically go through some flow testing, make sure that it was the right amount. So we run, I believe it's a 4-gallon. I think it's 4 gallon per hour or something along those lines, nozzle. Each one of them has check valves on them. So the nice thing about that is, even if it's not shooting, it's not drawing, it's not pulling vacuum on the lines and stuff like that. It's not putting stress on the solenoid and further down onto the pump and everything else. So what we try to do there is make something that as soon as it asks for meth, it's instant. You don't have a delay. So when you go to tune it, when you're trying to adjust it, it's right on the money.
It runs into a lot of problems if it fails.
Yeah. So one of the things that we are actually telling people when they go to buy the kit is that we only run 100% meth or 80-20. So 80% methanol, 20% water. The reason why is because when you start adding more and more water to it, when you run 50-50 or even a lower mix of methanol to water, you actually start hampering your performance capabilities. What we found and through testing with ProMeth was that the 80-20 seemed to be like the pristine spot of cooling, but also fuel additive. Okay. And the nice thing about running the large sprayers that we're running in each one of the runners is that you can use this almost as, I don't want to say it as a substitute for upgraded injectors. It's more like a Band-Aid to it, but you can lean on that without stressing your injectors. So that's one of the things that's nice, that you can kind of lean on that system, maybe have a custom map specifically for it in your tuning. So if you're using like Ecutech, they can definitely do that within the tuning platform. So.
Okay.
So we're really excited about that. We've done some testing with it, and the power is definitely up. Weight, it's very, very noticeable on the power delivery side of the house. Cars that were running a little bit hot are actually running cooler just by being able to do this and cooling that charge intake air temp. So.
All right. So what other products have you done? Because we're going to save the turbos for a little bit later. So what other products have you done for the VR outside of that?
So right now we have our all-wheel drive solid transmission mounts.
Okay.
That thing is, I know Parash has one, and a few other members within the community have them. We haven't been advertising it because we kind of made those for our twin turbo kits. And we're like, all right, we're just going to go ahead and include these with the twin turbo kits. Right, and make it a package because the factory ones are just so weak, especially on the rear wheel drive. I mean, the amount of deflection you get on the rear wheel drive, it's insane. So we've worked with some other manufacturer or some other companies that want to manufacture them, and we've kind of helped out in that regard. So we're waiting for them to get their stuff out on the market, give them an opportunity, and then we'll be releasing our rear-wheel drive application a little bit later, hopefully this year. But in addition to that, we're working on a lot of different things. So we have our race intercooler. Nice thing about that is the technology in that I'm pulling from like years of experience of racing and what we can do to kind of make this better. We've run probably about 5 different prototypes on different designs on how to package the intercoolers.
Okay.
So right now we're with the integrated blow-off valve. I'll probably be able to send you some pictures on that, so you can probably share with your people. It still has the RJM logo on it because it was prototype.
Yeah, I remember. This is from about almost 2 years ago, right? They've been working on this.
Yeah. So we've been working on it for a while. We've made a bunch of different prototypes, and so we actually took one of our designs and we decided to, we're going to add the blow-off valves to it and really see what we can do. So we're using 50-millimeter blow-off valves, more than you'll ever need, but it'll allow you to scale up to that quad digits if you ever needed to without having to replace anything. The nice thing is that you actually declutter in between the intercooler and the turbo. When you go to add like those HKS or even turbo smarts down there, that's a lot of trying to get in there, finagle, get things to clamp and stuff like that. This makes things super simple, super clean, everything's super accessible. One of the things that we tested was between different passes of intercooler cores. Okay. So the first one we did was a single pass. So basically the coolant would go in one side and then we go right to the other side and go out. What we found is we weren't utilizing the full efficiency of the cores. And while we saw definite gains on it, I knew we could get more out of it. So I didn't want to just be like, okay, yeah, we're good to go. Let's just end it there. I wanted to make sure that what we did bring to market was going to be something that was just going to be just knock it out of the park, and especially paired with a heat exchanger. You got people sitting and idling and running and just running the cars hard aren't going to have any issues. So we went to a triple pass setup, and so for your viewers,
packaging right there.
So it's a little bit larger than a factory intercooler core. It's more efficient based on the tubing design, the fin design. And then what we did was we designed the water end caps to allow us to run the coolant through one side, back across, and then back across again. So what that does is the first time that fluid comes in, it pressurizes and it's really fast moving across. And so you get that first sweep of coolant and heat away from the air. And then as it comes back, it slows down a little bit more. And then as it comes back, it slows down a little bit more. So by doing so, you're actually giving it more dwell time to actually pull more heat out of the air. So that's one of the benefits of doing that.
That's definitely
we also went. Yeah, more consistent. We'll be doing some full spread like white papers on it, pretty much showcasing what the dwell times are. We're going to compare it to a stock similar vehicle. So it's definitely going to be something to look forward to when we get the opportunity to publish that. So.
Okay, so pretty much that's it. I mean, there's no more things.
No, there's a ton more. I could probably go on for like an hour of all the different products, why we design things a certain way.
Yeah.
But I want to be respectful of your time and your audience's time. I know people tend to have a limited.
We are here so I can pick at your mind. You know what I'm saying?
Yeah.
Like that's what it is. And for the people that are watching, they're super appreciative of that because they like to see what's down the pipeline for the community, especially that the 400Z is going to come out. knowing that your
Mm-hmm.
company is one of the companies that's releasing a lot of the components for this motor. So if that VR30 is going into 400Z, you already a step ahead, you know? So
Yeah.
I think this is one
Yeah.
of the best times
That's the
to share with
gamble.
people. Yeah, you know, it's a gamble.
Yeah.
But even then, knowing that the Q50 is one of the top cars on the road, a lot more people are purchasing these cars. Like you said, the budget price is going to get a lot more affordable, so more people are purchasing it. But there are people
Mm-hmm.
within those groups that want to aim for higher horsepower. So I'm one of those guys, hopefully. And so let's talk about this turbo kit now.
Yeah.
Jump right into it. Talk about the specs of the turbo, what may be the prerequisite of it, and just jumping right into it, you know?
Okay, so let me talk about the problem statement, right?
No problem.
So the problem statement is going to be, you want to get more power. You look at the factory turbos. A lot of people, the reason why they end up killing those turbos, they're overspinning them. A lot of that time it's not the guys that have red sports because they have the speed sensors, and the ECU can better handle and control the spool and the speed of those turbos, so they tend to last a little longer.
Mm-hmm.
What you get is the guys with premiums and luxes, when they actually start to really try to push it, keep up with the red sports, they end up, getting, seals, deteriorating, smoking. And something that we haven't told anyone yet, but we've actually found out with the VR30 motors, is that they're not consistent cylinder to cylinder. So what most people don't understand, and this is kind of what we've actually found out through some of the builds that we're doing. We're actually building a couple of big power builds. So one of the things that we found is that some of the cylinders could be off by 6 thou in one cylinder, 1 thou in another, and then another 2 or 4 thou in consecutive cylinders. So when you start to actually put ring gaps and you're trying to actually make a consistent build and something that's not going to rattle and knock around, that becomes more difficult. I mean, we've seen this as low as motors with 2,500 miles on them, being 6,000 off.
Wow.
Out around. So, at that point, one of the things that we're actually looking at is we actually have dry sleeves. When the VR30 motor first came out, we started working with LA sleeves. We got them a motor. And actually started the process of developing a dry sleeve for it. Okay. So unlike a mid sleeve, which you pretty much getting rid of a lot of the cylinder wall, a dry sleeve retains that factory structure but has a shelf at the top to not allow it to drop. So you're actually able to get uniformity out of it. A lot of people ask, well, why can't it just go like a 97 or is it 87 millimeter piston if it's 86 millimeter piston from the factory? Well, the problem is that there's a special coating on the cylinder walls, so you cannot go back and bore and hone them without damaging that coating.
Okay.
And most people don't realize that. So that coating is there for a specific reason. The material that they use, once you destroy that coating and get it off the cylinder, it's pretty much scrap unless you go in and you dry sleeve it. Okay. And that's what we found from our testing on it. AMS may argue differently. That's fine. Totally fine with that. But from our testing and what we've seen from like corrosion resistance and the surface quality of the material, it's not something we were willing to gamble on. So a lot of the builds, if we see inconsistency on, we automatically recommend getting the dry sleeves. It's about $1,200 for the whole process. Okay. But when the GTRs do this, they're pretty much bulletproof. I mean, I ran this in my race motor. I run in my race motor now at 40 plus PSI,
ain't going
over 1,000 wheel horsepower. You can detonate it till the cows come home. You're not going to have any problems with the actual cylinder wall structure. Having the closed deck block is another benefit to it as well, because you're not getting actual, migration of the cylinder walls.
Okay.
So back to the problem statements. You start looking at guys are blowing out the factory turbos, and you start looking at, okay, what's the next step? Well, you have other manufacturers out there that are actually taking the cold side housing and they're actually milling it out, and they're fitting a larger compressor wheel on the turbo. One of the benefits of this is that you're actually able to expand the breadth of that turbo. But one of the disadvantages is now you are adding more centrifugal weight that the bearings and the seals have to deal with. So we've seen a few guys that have come back after having those turbos and be like, I'm blowing seals faster.
Yep. Yeah.
So,
A few people, they come to
yeah.
me and they say, hey, listen, this is the problem I'm having. I'm just like, you know?
Yeah. So, when we saw that, we were like, well, the best way to do this is to try to get an appropriately sized turbo. And so one of the things we wanted to do was make sure that we were mating up the proper ratio of turbine side housing to the compressor wheel housing, or compressor wheel. So the turbine wheel to the compressor wheel. We wanted to make sure we got a good ratio there. So for those who are like wanting like as close to factory as possible, we're going to push them to the G25 550 with a smaller AR housing for the turbine, probably like a .76 to get it to spool as fast as possible, but still make good power. It's definitely going to make over 800 wheel horsepower. We're not worried about that. Our concern is more on what's the spool response on it, what's the drivability of it. So that's one of the things we did with flow testing with our turbo manifold and things of that nature. So we wanted to make sure that we weren't obstructing, making the run too long. So we try to make it as close to bolting a turbo to the head as possible. So one of we looked at different turbos. We looked at EFRs, we've looked at precision turbos, we've looked at Zonas. We finally settled on the Garretts because the Garretts are absolutely consistent. I used to work for Honeywell when Honeywell owned Garrett, so I got to talk to a lot of the engineers there and to see how they deal with things. And I was thoroughly impressed with how they approach stuff. And when I heard they were going to come out with the new G series, I was like, that's going to be the bee's knees right there, because it's truly a 25 series turbo that's punching way above its weight class. The 25 660 is punching at the weight class of a 35 series turbo, a GTX 35, and the 550 is punching at a 30 series turbo weight. So at that point it's like it makes no sense to go anywhere else. EFR, we tried that, looking at that, but they don't offer reverse rotation, and that becomes a problem. And you'll see one of the guys, I think it's Ryan, he's doing his own build in his garage,
Q60,
and I'm trying to give him some advice on it and saying, hey, you need to look at that passenger side, because when you don't run a reverse rotation, that passenger side actually lifts up like this. So you're not able to actually pull it tight and tuck it in, especially
he was
with an
talking
all-wheel
about
drive
how
car.
the pivot was off so much more on the passenger.
Right, and so you only have about 6 1/4 inches between the head to the frame rail. So it's very, very tight. And so to fit these turbos, I mean, our compressor wheels are on the 660 are literally, we get like maybe 1/4 of an inch, 1/8 of an inch between the frame rail and the turbo compressor housing. So, and we have to clock it a certain way so that it will fit. Otherwise, you're going to hit the frame rail. So we're trying to make sure that when we do this, we're doing the due diligence to make sure that once you put it in, it's a one-time go in. You don't have to worry about good, clean fitment. So as far as from specs, we'll try to keep people on the lower AR side just so they get the turbo response that they want, especially given this is a small displacement motor. So we're going to try to really try to handle that. We're still doing fitment testing right now. We have a car that we're about to put these turbos on. We're just waiting for machine time so that we can actually get in and do what we need to do. So so one of the things that we are addressing is with the kits, we're addressing the AC compressor alignment issue that a lot of people are experiencing. So we're making, to fit a turbo in that location, you actually have to clock and rotate the AC compressor. So we've designed new front brackets as well as the rear bracket to hold the AC compressor in place. And then we also made new lines that will come with a kit for the AC compressor. So new adapters and lines to move it around the turbo. So this will be something that'll be really, it's way we're pitching this. This is going to be something a shop needs to do. This isn't something you want to do in your garage, especially given the tools that are going to be needed, working with the AC system, being able to properly pull the refrigerant out without venting it to atmosphere and causing harm to the environment. So those are types of things that we want people to be aware of. So, do you have any specific questions about the turbo kit? Like, there's
Oh,
some stuff
yeah,
I can
yeah.
talk about, some stuff I can't. Yeah.
I just really wanted you to get that stuff out because I'm learning too.
Yeah.
People that are watching, they're learning. But some of the specific questions that people ask is one of the top ones from Envious FA1. He says, how much are these new turbo upgrades? At least a ballpark. Just a ballpark.
We're trying to keep these things under 10 grand.
Yeah.
You know, people have to remember, like, when you're looking at these turbos, these aren't cheap turbos. They're about $2,000 a pop. Yeah, yeah. So the retail, I think, is like $2,200 each. So, you know, if you take that into consideration, that's $4,400 right there, just in cost.
Mm-hmm.
You know, we may be able to work something out with Garrett. You know, I could probably pull some strings with some of my contacts there, so you can get some better pricing and bring that price down.
Yeah.
But only time will tell when we go into actual production mode for that.
Okay.
We're also replacing the factory engine brackets. That was another thing I was bringing up to Ryan, was that he's got to make, you know, new brackets for that.
Mm-hmm.
So we're making both for all-wheel drive and rear-wheel drive. That will come with billet aluminum brackets.
Okay.
So that'll basically go from the engine to your motor mount, and these will basically accommodate for the AC compressor, for your starter, and then also for your turbos and all the lines associated to that. And then we're making adapters for the coolant. We're making adapters for your oil lines. We're trying to go AN on the oil lines. We're having to make new adapters to actually go into the block and allow you to put a 4AN line
Okay.
from the oil feed, I guess
pretty
the
much
oil return
oil
line,
line.
and then yeah. So try to make it as robust as possible, so you don't have to worry about any issues.
Let me see if there's any other questions here. Jazz, I guess, is just jumping in. He said, what's the power level, the different power levels between the two different, the 550 and the 660, right?
Yeah, so basically we're calling them the 800R and the 1000R kits, mainly because, you know, we're going to probably advertise it around 800 wheel horsepower, and then once we get numbers for the 1000R kit, it'll either we're fairly confident we'll be able to make it. We're still running 10.2 compression ratio.
Mm-hmm.
Stock, basically, you know, just built bottom end.
Mm-hmm.
We have a car right now that's getting the 660 kit put on it.
Mm-hmm.
We have another car that's getting a 550 kit put on it. Actually, we have a couple that are getting the 550s. So we're fully confident. They're full transmission builds, full rear end builds, you know, upgraded drive shafts, axles, like everything you can do to beef up this system, we're doing it. They're all getting dry sleeve. They're all getting billet main girdle reinforcements, you know, closed deck blocks. I mean, these are pretty much going to be race cars. They're getting the 600 kits. So if we want, we could talk about the compressor mappings. So, you know, one of the things that when we were looking for turbos, we were actually comparing compressor maps.
Okay.
What this allows us to do is to look at at what boost levels should we expect efficiencies.
Mm-hmm.
You know, and one of the reasons why we went to the 550 and the 660s, because, you know, when you're running a twin setup on a 550, you're still in that upper 70 percentile island on the compressor map.
Okay.
You know, making 800 wheel horsepower. You know, that's what you're looking at, is you're going to be, you know, really in the efficiency band of that 550 and around 800 wheel horsepower. Some guys have seen, you know, on single turbo applications, 500 plus wheel horsepower on a 550.
Yeah.
So, you know, there's definitely, there's definitely room to grow on it. But, you know, again, we want to stay a little bit conservative on it. We know that the 550 will definitely do better than the GTX 28 series that others have attempted to use. We want to make sure that,
those are turbos that are on Sam's car, right?
I'm not sure if they're on Sam's car. I know some other people have tried the 28 series.
I believe he does.
Yeah.
I think that's
so I mean those. Yeah, you're looking at, with the GTX 28 series or GT 28 series, you're looking at pretty much, you know, around 800 wheel horsepower, mid 800s, maybe 900. That's pretty much going to be the limitation. You're going to be dropping off your efficiency islands there, and you're going to start running at, you know, turbo speed limitations. So, you know, a lot of guys are used to the factory turbo spinning like 300K. When you get to these bigger turbos, you're not spinning near that. You're spinning maybe 140,000 RPMs. So, and that's really pushing some of these bigger turbos. But again, you have a larger centrifugal mass,
Yep.
you know, so you want to make sure you keep that in check without blowing seals.
And reliability goes up when you have slower turbine speeds, right?
That's right. You know, you get a better reliability out of it. So yeah, I think that's one of the reasons why we sized them the way we did, was to say, hey, you know, we could try to stretch a 550 up to 1,000 wheel horsepower. It's probably very doable. The issue that you run into is that compressor speed one, and then also looking at, you know, the pressure ratio you have to run to get there.
Okay.
You know, you're going to be running, you know, close, you know, high 30s, low 40 psi to be able to get there. You know, that's if you're looking at it from the mathematics side of it and looking at the compressor maps. Yeah, to be able to stretch it that far. So
I mean, yeah. So, all right. So there's a few questions. Bear with me, brother.
Yeah, no problem.
VR30 asks, when is the myth injection done? Isn't it already done?
It's already done. It's ready. We have one slot left on the group buy for it. I'm actually waiting for one more customer to get in there to get in on the good deal.
Okay.
I believe we had it set up as $1,400 for the full kit. That's, you know, everything that you would need to be able to run this. So from soup to nuts, from trunk to engine bay. Yeah, it's a little expensive, but you know, it's, again, it's one of those things. There's not any direct port injection ones that are going to be, you know, that 11, 1200. You'll find, you know, single sprayers or twin sprayers that will do that. And we may look at doing something for that as well, so that, you know, if somebody wanted to do that, maybe make it a little bit more cost effective. We can probably do a pre-turbo setup to where you can spray pre-turbo, lower your charge intake air temps. And we may even look at like a pre-intercooler sprayer. So after it comes through the turbine, you're cooling it down before even the intercoolers get it. So, you know, those are some other options that we're looking at as well. So,
all right. Envious says, well, pretty much he says, do you have any efficiency islands for that you can post? But that should be on the Garrett site. I remember, right? Don't they have?
Yeah, that's one of the great things about Garrett in general as a company is they'll give you everything from full turbo diagrams to, you know, what matters in turbo diagrams, and then also your compressor maps. So one of the things that people have to remember when you're trying to do that, what they're doing is doing pounds per minute, I believe, on the bottom line, and then you have pressure ratio that goes up the vertical axis, and then you have these efficiency islands out here. Now, the thing you have to pay attention to, especially when you're comparing like EFR to like Garrett, EFR does or was it Borg Warner does something funny with theirs. They change the scale of theirs as it goes across the x-axis, which to me is deceptive in practice, because what it does is it elongates that graph. And so people think it has a broader graph or broader islands to be able to do that. So they'll do like every 5 increments, and then they'll go to 10. And it just like, or I think they were doing like 10 and then would go to 5, and just like spreading the whole thing out.
Okay.
So that's one of the things that made it very difficult when I was like going through their compressor maps. I was going through Garrett's, and I was like, all right, now I got to figure out where the scaling is on this.
Okay.
Because you're having to pick in between lines and just trying to say, all right, let me measure this out. Let me see where we are on this. So the thing is, when you're calculating those pressure ratios on that vertical axis, what you're going to do is you're going to take the amount of boost that you want to run. You're going to add 14.7, which is the atmospheric pressure. And then what you're going to do is you're going to divide by 14.7. A lot of people don't know how to read compressor maps, and this is a good way for Garrett has a full article on this. They have white papers on how to do this. So once you do that, it'll give you a ratio, whether it's 2.2 or 2.3. And at that point, what you're going to do is you're going to trace that all the way across with a ruler, find out where you want to be on power level. And that's going to, you'll have bands that go across like that. That's going to be your speed of the compressor wheel. And then those islands are your efficiency, how well the turbo is going to respond to power. And then, so again, higher the number, the better the efficiency, the more it's going to respond. The lower the number, you know, the less efficient, the more struggling you're going to get with that turbo. So you're going to get more hot air. It's going to just be churning and not really making as much power.
PSI goes up, the charge attempts go up. That's it.
Right. So what we try to do is find something that matched that. So that also goes into, you know, more detail of why we chose the 550 for one application, 660 for another. So, you know, and then basically what you want to do is you want to draw your line up and then draw your line across. So yeah, so, and then that gives you a point of reference. So say you want to run 20 PSI, you know, it's going to give you 450 or 45 pounds per minute. Usually what people do is they do a 10 multiplier to that, and that usually relates to crank horsepower. But in real world application, it gets really, really close to real wheel horsepower.
Yeah, I never
wheel
understood
horsepower
that part.
versus,
That part always confused me.
yeah, so based off the compressor map, like every engine is different. So you have to look at volumetric efficiency of the motor. They're like fueling, what fuel you're using. Yeah, there's a lot that goes into actually getting the actual number. But if you're looking for a ballpark and you want to understand where these turbos lie, the best way to do is do that mapping, find that point of what pressure you want to run. And then at that point, you can say, okay, with 2 of these, it's probably going to be around, you know, say if it's 50 pounds per minute, 2 of them is probably going to be a 1,000 pounds, or was it 100 pounds per minute, which is 1,000 brake horsepower. And then you take your drivetrain loss into effect for that. That's being extremely conservative. And so we try to do our numbers based off the conservative side of things, because, you know, it's easy to be optimistic, but, you know, we want to make sure that what we're doing is being very honest to people and say, hey, you know, we want it to be this, we hope it does this, but we're being very realistic and pragmatic about it and saying, you know, this is the reality to expect.
All right, so Sleepy Q50 says, ooh, these prices of pure turbos, it is. So if you were going to compare, right, let's say somebody, in my sense, let's say somebody wants to purchase a kit and just kept it on low boost, because pure right now are being stretched at 600 wheel. I know you already see that.
Yeah.
Let's say somebody wanted to go get your kit and they say, listen, I wanted to run it at 600 wheel, 93 fuel, low boost. Is that something that's definitely possible with the?
Oh yeah, the 550 kit all day long. That's what we're trying to pitch. The 550 kit is more of your daily driver kind of guy. The guy who just wants to have a little bit more power, doesn't really, you know, is going to put the fuel upgrades in, you know, not so worried about, you know, you want reliability. So what we're going to be, you're going to be doing, you're going to be underspinning the turbo, you know, compared to its true potential, but giving you growth opportunities. You know, when you start talking about, you know, what are some prerequisites, right? When you're doing this, you know, one, built bottom end for one. You know, the second you start adding more pressure, you start throwing more air with that pressure, you're going to start bending rods. And, you know, the first thing it's probably going to do is rod bearings are going to go. And then you're probably going to have a broken rod, because I believe the factory ones are powder metal rods. So if they're anything like the VHR or the VQ motors, you know, really the limitations of those powder rods we've seen from Nissan has been about 550 foot-pounds of torque. You know, some people, that's kind of like that verge of safety factor right there. And you're like going, okay, you know, after this is degradation time, you know, like, you know, you're gambling with time at that point. We've seen guys run 700 horsepower out of the VQ motors on the factory rods and pistons. I ran a G37 twin turbo at about 700 wheel horsepower, and just leaving a gas pump, literally pulling out the gas pump, threw a rod through the block. So had 3 cracked pistons and threw a rod through the block, and literally just left oil everything. I just coasted right to a parking spot and just left the car there.
It's pretty much a ticking time bomb, basically. At some point.
Yeah, you never know when it's going to hit you. So we often tell people, you know, if you're going to go big turbo, you're going to be pulling the motor anyway. Build it. Just bite the bullet, build it. We'll be offering some, hopefully some short block packages that are going to be on the shelf, hopefully within the next year. So people won't have to wait for it. So once we get our rods done, we're going to start looking at building blocks and just having them on the shelf, which, you know, right now in the COVID world in the motorsports industry is going to be very hard to come by. We talked with Manley about getting rods for a couple of our builds, and we were told an undisclosed, like, ETA, like, we can't give you ETAs, we're backlogged, you know, given they're out of California and everything, you know, the restrictions, you know, that really puts them in a position where they can't, you know, really feed the demand that's there. We talked to Carrillo. We had worked with them on a design previously with RJM and come up with a custom spec for that. But again, waiting time. At that point, we're like, you know, we're just going to take our custom spec. We're going to build our own. And at that point, you know, that's where we came out with the billet rod design that we hopefully will be in product. We'll do a production run in 3 weeks.
Okay, that's great.
So, yeah, so there'll be rods available. Hopefully, following that, we're going to do first articles, and then basically we're going to do all our testing on that, and then that's going to become available. The other thing that we were looking at is the transmissions. Transmissions, you know, that's another, everyone's like switching the Q50, Q60 transmissions and the 370s and G37s. But again, you know, there's going to be limitations there. So, you know, that's something that when people start adding these bigger turbos, they're going to have more prone failures. You know, that's the next thing down the chain. You know, you build the block. The next thing is going to take all the abuse is the transmission. What you'll find is fifth gear, sixth gear, and seventh gear are going to be the ones that let go. Your first, second, and third aren't.
Really?
So we'll probably, you know, start pushing, you know, some of the same things that we did for the VQ transmissions for the VR transmissions.
But why would the fifth, sixth, and seventh gear go? I'm actually very curious on that.
Because when you're putting that power down and the actual the drive ratio for those, you're going to end up breaking teeth off of the planetary gears. And then you'll start getting slip clutches and things of that nature because they're going to take a lot more heat. So if you're doing pulls in like fifth gear or sixth gear pulls, like on the highway and stuff like that, you're putting a lot of load on that transmission, and it's going to eventually wear out those components.
Yeah, I never knew that. See, look, I would assume that the first, second, and third would actually go, but
no, they're actually pretty stout. The first, second, and third are pretty stout. I mean, if it comes down to it, we may look at, you know, doing manufacturing of new gears and maybe seeing if we see enough of those. I mean, with our Whipple kit, we found a lot of failure points with the factory transmission. We did an event with one of our initial cars at 550 foot-pounds of torque. Or no, I think it was 450 foot-pounds of torque, 550 wheel horsepower, stock block, stock transmission. Did rides for everybody, did burnouts, donuts, you know, just had a good time with it. Let the owner of the car take it out, run the tail of the dragon with it. My car ended up dropping its differential on the way home. So we had to end up putting that in the trailer, and I had to drive that car back, their car back. And when we end up pulling it apart, like literally as we pulled the transmission apart, we're putting the new built one in, the planetary gears just like crumbled in our hands. We were like, oh shit.
Man.
So,
man, you've seen it all. You've seen it all, man. I'm new to this, so like this is like something that's way above me, you know, but I'm just glad to have somebody here with so much experience. Go through much more questions here.
Yeah.
Beginning of say blood. Let me see. Okay, someone says something about how, because this guy boosted F30. Do you have an IG page that you want to tell anybody right now that's watching? Like an IG page that they can follow?
The company doesn't have an Instagram page. We're solely kind of just Facebook right now. And then we're looking at probably expanding a YouTube. We're actually talking with a couple of partners. So there may be some news coming up with the launch of the new Z. So you may see some changes within our company structure and stuff along those lines. Hint, hint. You know, we're trying to make sure that, you know, we're just staying in our lane right now, not trying to go too far out, given some of the discussions for possible changes in the future. So,
okay, I'm just going through some of the responses. Okay, VR30 pretty much. I think VR30 Garcia came in a little bit too late, but would you just be able to run these turbos without built internals? Like, can you be able to do so?
Yeah, you could. You're going to have to run them really, really, really light. I wouldn't like 550, and you're going to be running the smallest they are. The only concern that you're going to be on borrowed time.
Okay.
You know, AMS will tell you the same thing with their kit. You know, you go to a big turbo, you're going to be on borrowed time. So
VR30, he just adds the pricing. He's trying to have it under 10K, like as he stated. Like fuel kit. Bear with me. I'm just going through any of the responses Mike said. Well, okay. So yeah, people actually are answering in the thread. Someone says, how much boost do these turbos make? I think you answered that, between 30 to 40 psi.
Well, it's going to depend on your application.
Okay.
I mean, and where you want it to be. So depending on your power goals, depends on which one you're going to get. We'll give you recommendations depending on your, like, you know, again, street car, do the 550s, you get the best full response. You'll be able to make more than you need. You know, you're probably not going to be running near as much power or boost that you are, not power, but you won't be running near as much boost as you would be with a factory turbo. I know a lot of guys are pushing like 28 plus, 30 plus PSI with these factory turbos. You're not going to, if you did that, you're going to be up into the, you know, close to 1,000 horsepower range.
I was going to go block, holding
Yep.
it. All right. And a few other prerequisites. What about fueling here? Let's say on 93 fuel.
Yeah. So one of the things that we were talking about as far as from a fueling perspective, so we have our port meth injection kit, right? The direct port meth injection. We're also doing port fuel injection kit. That we have, we've already done our final design on it. We're again waiting on machine time. Hopefully in 3 weeks, we should have about 3 weeks of machine time available to us that we've allocated. So we're going to hopefully have that in our 5-axis CNC machine to be able to actually start running that. Once we have that, we're going to do final testing with that. Like I said, we have a couple of cars that we'll be doing testing with that on. We'll be using a split-second controller. We've already talked with them, made sure to go over with that. It's not a sequential injector, so you're not really using ECU to fire these individually like you would a direct injection system. It will be batch fired, so we'll be working with a couple tuners, you know, Racebox being one of them. You know, we'll be talking with like Eugene out in California with his infiniti tuning stuff with EcuTech. And then we've actually been talking with like John Hood over at UpRev. We're trying to make our stuff as platform agnostic as possible. And I know John's got some stuff up his sleeve that he's looking to release. So hopefully when he releases that, we'll have you know, a full gamut of tuning suites available for people and something that'll be user friendly. So the port injection is the one aspect of it. I would definitely suggest upgraded direct injection if you're not doing the direct meth kit or the direct fuel port injection. The high pressure fuel pumps are going to be quintessential to that. You know, given AMS's, you know, article they brought out in regards to, you know, causes for failures for fuel injectors, we had already dabbled with the idea of doing a fuel rail, a high pressure fuel rail. So we're still back and forth on that. We don't necessarily know if that's truly the cause for a lot of these failures for the injectors. Yeah, we've done some testing. We put 10 micron filters prior to the fuel rails, you know, from the line coming in, and we have not seen any damage to those 10 micron filters. So, you know, at that point, we're kind of going, okay, we don't really know what's causing it. We've stripped fuel rails down with acid, stripped them down to where there's nothing left in it, coatings or anything. Still had failures. So, you know, at that point, it's like, all right, you know, we don't really know what truly is the cause at this point. So we're debating it. We've had a couple people ask us for fuel rails, for billet fuel rails. So we may do it. But, you know, at this point, I can't confirm one way or the other.
If there's no demand, it ain't getting made, guys.
Yeah. So, I mean, if you guys want it, you got to ask us for it. Because, I mean, at this point, we're a lot on the bleeding edge of things. You know, a lot of people aren't making a lot of the products for this platform. So, you know, if we're going out there, we're going to make this stuff. We need your support, like, you know, because that's the only way we survive as a company, you know, especially dedicating all our time to the VR30 and Nissan and Infiniti platforms. We aren't like AMS. We're not hitting all these other Porsches and, you know, Audi and all this other stuff. You know, we're solely focused on you guys. So that's our primary bread and butter. So
yeah, I'm super excited, man. So in my own case, what I would sit there and say is, I still don't know if I'm going to purchase the kit, but I wanted to be able to just to give all my following the best information they can from the man himself, so that guys can make the decision in the next 6 months if this is something they want to jump into. Some people don't want to go full 85 balls to the wall. Some people might just want to sit there and say, you know, pure turbos are about $4,000 to $5,000, depending on what it is. And they're like, you know what? I'm going to own this car. You know, I want to be able to purchase turbos that have growth, so I can put it low boost, 93, or even E85 low boost, and call it a day. But then later down the line, I say, you know what? Let me just go get some rods, some pistons, and bearings. Let me build a block, and now I'm 700, 800, 900 wheel horsepower transmission, and it can go full send down the line as you know as it goes, as the platform gets even better. So it's just a decision. It's a long-term decision that, you know, you think about longevity-wise. Because right now, I'm getting rid of my RT turbos because I'm like, after I know a few people that lost their RT turbos, I said no. And then a few people I know at Pure hit me up, and I'm like, no. I'm just like, I'd rather do it one time and one time only, and then have that growth. And I want everyone that's watching to be able to do so too. You know?
Yeah, and we're here to work with you guys and make sure that, you know, if it's something that's where, you know, you guys want to get into something and you want to do something, we'll work with you on price. I mean, we have some flexibility in that, but at the same time, you know, we're a small company. We're not AMS big. You know, there's only a handful of us, and we're not taking pay salaries for this. Like right now, all the money that you guys spend with us doesn't go to me directly. It goes right back into the business.
That's it.
Do R&D, manufacture parts. Yeah. So, you know, we actually have it in our organizational structure. We don't take, you know, profits from the business until year so-and-so and this much revenue that's actually come into the business outside of our R&D budget, because we're very R&D focused.
All right. So for everyone's watching, can you just give everybody your website, all your social medias, because people might just want to go look some of this stuff up?
So we're mainly focused on Facebook right now. So it's at Dropbear LLC. So if you put in Dropbear LLC, we'll be the first ones to come up. We're working on a website right now, but you know, that's going to come in time. Like I said, there's some possible news that may come out, you know, when the new Z comes out that may change things a little bit. So that's what we're trying to keep it as light as possible right now. We don't want to do too much rebranding if there is a rebranding that happens. So.
Okay. All right, guys. So for everyone that's watching on IG, this is Mike Mixon from Dropbear LLC, and he was just talking about the different parts that are out and that are coming out for the VR30 platform, some of his history. So definitely check on some of the old videos and everything like that. So guys, just definitely check him out so much. He's gonna come out with IG hopefully soon, because people like the accessibility of being able to just jump to different platforms and look up information. And a lot of people are actually saying thanks, Mike. A lot of people are saying thanks in the IG, which is actually good, you know. And I'm just super appreciative of you coming on and just giving out the information, because we need it. We honestly need it. And you know, I'm just so super thankful for you just coming on this live, because this is my first time ever doing a Zoom live too. So it's my first course at it. So I'm just super appreciative of it, brother. I'm gonna see you later. We'll talk later and everything like that. Everyone on IG, I'm gonna go live a little bit after this just to hang out and talk with you guys too. Mike, I don't know if you have an Instagram, like a regular person with Instagram, but if you can go over the, don't add me there if you have a regular.
So I'll leave my personal one out of it, because
I don't put it out there. But if you want to join the chat, you know, it is what it is. But otherwise than that, guys, signing out. You already know where to contact me, boostinmotion IG and Facebook, boostinmotion@gmail.com. I'm going to try to put some of the links to his Facebook group page on the everything like that. This video is going to come out like a week later and everything like that. So otherwise than that, this is Mike Mixon with Boost Motion, and this is the first ever interview. Thank you, guys. Appreciate it.
All right. Thanks, John.